Okay, let's continue with this. So, in the last video, what we saw was z was cis theta, which is, cosine theta plus I sine theta. We saw that z to the n was cis n theta, so that was equal to cosine n theta plus I sine n theta. We saw that z conjugate, which actually was 1 over z, is cis negative theta, and we saw that because it's odd function, even an odd function, it ends up being cosine of theta minus I sine theta. And we saw that conjugate to the n, which is 1 over z to the n, is the same thing as cosine of n theta minus I sine of n theta. Okay, so we have two things. We're going to combine two things together. Z to the n plus 1. Z to the n, z plus 1 over z is, we have cosine plus cosine, so that's 2 cosine theta, and then I sine theta minus sine theta, So we have this interesting identity here. This is kind of interesting, right? We also, if we do, that means that z to the n plus I to z to the n is equal to 2 cosine n theta. That's kind of interesting. We need that. Another thing we need to look at is z minus 1 over z, which is equal to 2, well, if we subtract them, so cosine minus cosine gives us 0, but I sine minus negative I sine gives us 2I sine theta. Interesting. And I'm running out of pens. Where is my pen? There's another pen here. And sorry about that. I'll find another pen. Sorry. We use brown. There you go. And we know that z to the n plus 1 over z to the n is equal to 2I sine and theta. Okay. Now, we're going to talk about cosine. So the question is, cosine to the 6th power. How do you find cosine to the 6th power? Well, watch. You're going to like this. So the question is, how do we find the integral of cosine 6 theta d theta? Now, we don't want to do all that, writing it as like cosine to the 5th and then substitution, and then you have to like expand. Is there a first way? The answer is yes. So we know that 2 cosine, we know 2 cosine n theta is equal to, we know that, I apologize. We know that z plus 1 over z is equal to 2 cosine theta. Well, that means I could raise this to the 6th power. And so I now have 32 cosine 6 theta. Well, let's expand that out. So we have 32 cosine 6 is equal to z plus 1 over z to the 6th power. Well, we know how to do that quickly. Can you see it on the board? Yeah, we can do this quickly, right? Because we know it's z to the 6 plus, well, hold on one second. Remember, we have to put on Pascal's triangle. So I'm going to quickly do that on the side because I don't remember what the 6, let's see, it's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. This is 6, and now we need 7. 1, 6, 15, 20, 15, 6, 1. So we know this is 1 z to the 6th, z to the 5th over z, right, because it's z to the 4th, that's 6. Oh, sorry. Sorry, let me slow this down. I apologize, because I'm excited to teach this. So let's go through this. Let's do the exponent first. First, we know it's z to the 6th, 1 over z to the 0. Then we know it's z to the 5th, 1 over z to the 1st. Then we know it's z to the 4th, 1 over z squared. Then we know it's z to the 3rd, 1 over z cubed. We know it's z squared, 1 over z to the 4th. We know it's z, 1 over z to the 5th. And last but not least, we know it's 1 over z to the 6th. Okay? Now we put on Pascal's triangle's coefficients. We know it's 1, 6, 15, 20, 15, 6, 1. Let's clean this up and make it nice and pretty. We have this equals to, ready? Z to the 6th plus 6z to the 4th plus 15z squared plus 20 plus 15 over z squared plus 6 over z to the 4th plus 1 over z to the 6th. Ready? Because you'll like this next one. So you're like, Mr. Rather, what are we going to do with all this? Well, you know what? Z to the 6th and z to the 1/6, let's bring them together. Let's take plus 6 times z to the 4th plus 1 over z to the 4th. Let's bring those together. Let's bring 15 z squared plus 1 over z squared, and then plus 20. Now let's clean this up. I wish I had my black marker, but I wish I had a black marker. I guess I don't have it. I'm going to have to work with that. That's fine. We're good. So, what is z to the 6 times 1 z to the 6 times 1 over z to the 6? 2 cosine 6 theta. What is z to the 4th times 1 over z to the 4th? 2 cosine 4 theta. What is z squared plus 1 over z squared? 2 cosine 2 theta. Plus 20. We're almost done here. What have we done? We've transformed our power of cosine into multiples of an angle. I'm going to multiply the 6 and the 2, the 15 and the 2, and I'm going to divide out that 32. So we can say cosine of 6 theta is equal to cosine of 6 theta, I apologize, cosine to the 6th power is equal to 1 over 16 cosine 6 theta plus 12 over 32, 6 over 16, 3 over 8, cosine of 4 theta plus 30 over 32, 15 over 16, plus 20 over 32, what is that? Dividing by 4s, that is 5 over 8. And now, you have a quick, it's not so quick, but you have an interesting way to convert a cosine or a sine to a power into the sum of trig functions with multiple angles, and now it's just really easy to take the integral. If I just take the integral of this, the original question was, what was the integral, right? So in this last step here, I guess I can use my red ink. The integral of this whole thing, this is easy now. What's the integral of this? This is sine 6 theta over 96. Because you know the substitution. U equals 6x, and then the u would come to the denominator. What's going on here? Well, once again, 3 over 32 sine of 4 theta, plus what's going on over here? 15 over 32 sine theta. What's going over here? This is plus 5 theta over 8 plus c. And that's how you do this. It may seem tedious, but it did show up on IB questions, and it has shown up in the book. Try on your own sine to the 5th. Try that one out with using this, and then we'll go over it in class again.